The shorter leg is 20 meters long, the longer leg is 21 meters, and the hypotenuse is 29 meters. Great work if you found all three. Now, the setup might have been tough, so if you got stuck there, watch part of the solution and then pause it and see if you can continue solving. To start setting up this problem, we'll let x be the shortest side of our right triangle. We do this since we know the longer leg of the right triangle is 1 meter more than the shorter leg. So we know this longer leg has to be x plus 1. And now here's where we want to be careful. We know the hypotenuse is 8 meters longer than the longer leg. So we'll take the length of the longer leg, x plus 1, and we'll add on 8 meters. So the entire length of our hypotenuse is x plus 1 plus 8, or just x plus 9. Now we have expressions for each side of our right triangle, and we can use the Pythagorean theorem to solve. We square x, which is one of the legs, and x plus 1, the other leg. This gives us these two expressions, and then we square the hypotenuse, x plus 9, to get this expression on the right-hand side of our equation. We combine the like terms here to get 2x squared, and the rest of our equation remains the same. Next, we subtract each of these terms from both sides of the equation, so we have 0 on the right, and x squared minus 16x minus 80 on the left. Next, we factor this expression to get x minus 20 times x plus 4 equals 0. We set each factor equal to 0, which means the solutions for x could be positive 20 or negative 4, the opposite sign of the factors in the parentheses. We know a negative side length for x wouldn't make sense in this case, because we would have negative 4 here. So this solution is not valid. When we plug in 20 for x in each of these expressions, we'll get our side lengths of 20, 21, and 29, with the hypotenuse being the longest one of 29 units. And since our original side lengths were reported in meters, we report each of these in meters.